I was searching online for some 24 volt LED tubelight in the hope that I could find some. I didn't find it. But what I did find was this listing for DC 24 volt 5 metre 50/50 LEDs, and it was like 5 metres, and I'm thinking that sounds ideal just for as a flat version of it, but £1.77? That's not right. So just out of interest, I ordered a couple just to see what actually came through. Secretly hoping it was going to be a listing and I was going to get sent full drums or like a big section of the tape. But this is what arrived. 2 1 metre sections without any end terminations or anything. So let's see what we can do about that. So this, I've been tracing it out. I don't think this is 24 volts, and certainly I tried it on my bench power supply set to 24 volts. On the end of the tape it's marked plus, so I looked at which wire that was on, so it's this side, so I connected 24 volts across, nothing, zilch, zero. And then I followed the set of tracks out, and I reckon this is 240 volt or 220 volt tape, just standard stuff as is so common. And based on that, it's got, along its full length, it's divided into 2 sections, which a lot of this stuff is to cater for the 120 volt versus 220 volt markets. And they're just joined together in the middle. This also caters for the half metre limitation of the printed circuit board material manufacturing that seems to be quite common in this scenario. So the resistors along it there's 9 in each section, and they're 300 ohms each, so when you add it up there's 18 of the resistors along the full length. The LEDs are all in parallel pairs, which seems quite common as well. So that makes, there's 60 LEDs, so that's 30 pairs, gives about 3 volts each, 90 volts along the full strip. Then you calculate resistors, there's 5,400 ohms, and if we do the maths, then say 240 volts minus the 90 volts is about 150, so 150 volts divided by that resistance, 5,400, equals about 28 milliamps, which means because they're in parallel pairs, that would be 14 milliamps per LED, which sounds realistic enough. Based on that as well, times to get the power dissipation for the resistors, that's the 27 milliamps times 150 volts dropped across them, gives about 4 watts divided by the 18 resistors, equals just under 1/4 of a watt each, so it seems to all tally up. I do wish that they've got plenty of room in this, it's all pick and place. They could have put a resistor in between every single pair instead of just every second pair, and that would have helped reduce the dissipation. They've done it in every sort of multiple. You see a resistor between every pair, but then it jumps to every second pair again, and if they just added those few extra resistors, it should make it reliable. So this didn't come with the end connections, and I'm thinking, well, let's see if we can make our own rectifier up, because this thing normally has, I've got a bit down here somewhere. This stuff normally has an end cap that goes on like this in spikes, and it's got an inline rectifier that converts the AC going into DC for the LEDs, and then that runs a significant length of the tubelight, or the strip. So I could try and pull this off and just use the connectors out of it. I think it'd be much more fun trying to improvise a way to connect onto this with a discrete rectifier. So let's build the rectifier first. And the rectifier is just 4 diodes, acting as a sort of electronic gate, if you will, that converts the AC to DC by providing sort of switched routes from, well, basically whatever polarity each input is, it will divert it to the positive or negative terminal accordingly. So I've twisted both the positive ends of that pair together, and now I'm going to twist both the negative ends of this pair together. Classic rectifier, even the classic shape of the rectifier. And then I'm going to put them like this, and these will be the 2 AC terminals. And I'm going to twist them together as well, roughly the similar spacing so it looks fairly symmetrical, to appease any autistic tendencies. And then I'm going to solder it. So let's do that, let's solder it right now. A very rough and ready. I could have used a pre-made bridge rectifier, but I didn't. I'm thinking I could have left those leads quite long. If I had left the leads a bit longer, I can still do that. I can unwind it a bit. I could have shoved the rectifier right up the end of the strip, the LED strip. If I've made a mistake here, then when I connect this up, it's going to draw lots of current, the LEDs are going to go pop, and the resistors will go pop as well. Oh well, if it happens, it happens. It's just it was just cheap stuff. So let's unravel this a wee bit. I can unravel it, so that's good. So let's crop that, a pair of snips. Generic cheap eBay snips this time. So let's see if we can just shove this up the end of the tape if I go like this. So that's the negative side, and that's the positive side. Technically speaking, I suppose I could. I could actually try and solder onto the end of these leads before they come out, but I'm going to try shoving it up. Positive. The end of this tape is marked positive. It's attaching to that leg, so I'll make this one the positive. Is this going to work? Am I going to be on a hiding to nothing here? I wonder if I should actually just... I might be better if I actually just crop it a slight diagonal slant, just so it pierces right up the inside of the wire. This is a very rough way of connecting this. So let's shove it up and see if it goes into the strands. It's resisting. Oh, it's not that happy. It's going in a way. No, it's not. Right, so can I nibble away at the plastic and expose some of those wires then? Maybe use a knife to slice around it. That would work. Maybe use a knife to slice my fingers. That would also work. Oh, actually it's quite slicing quite easily. Famous last words. Well, just like skin really. That's the peril of sharp knives. They're very useful, but occasionally you get yourself with one. So we've exposed the wires now, and I've got a little careless whisker sticking out there I'll have to deal with. So let's twist those together. I hope they're not aluminium, that would be annoying. I hope they take solder. We'll find out right now. They're not taking solder. I think they're aluminium. Damn. That's annoying. Oh, they are. They're just really not taking solder at all. Oh, that's annoying. Right. This is where little spikes would have been quite handy. Do I have anything I can use as spikes? I can't really think of anything I could use as spikes for that. Does anything come to mind for use as spikes? Nothing is immediately coming to mind for use as spikes. Let's just twist them together then. What's the worst could happen? So, negative is going on to that connection. Yeah, the colour of that wire is all wrong. It looks grey as opposed to the normal sort of like the slightly gold hint you'd get off tinning. And the positive is going over to that one. Oh, this is so going to pop off and go bang. You hope. Oh, I'm just going to hook that on then. That's very shady. So a couple of bits of wire now. So do. Doesn't really matter the polarity, because it's just going to be mains AC going in. Wire strippers. A modest, generous bit just to go into the quick test, and the other one just to tack onto these LEDs. This is where, if I disturb this, that wire is going to pop right off, isn't it? Yes, it is. Let's crop these down gently. And solder a wire on. Put a splosh of solder on there and a splosh of solder on here. Be lazy about it and just retin and flow them together. Reheat and flow. Good enough. rough but good enough. So I wonder, that listing's still up. It's very odd. So it says 5 meters of 24 volt, and yet they're sending out 1 meter of what appears to be 240 volt or 220 volt tape. So what I'll do here is I'll try this out. I'll give it a wee blast just in case it really does go bang. It may arc on that connection there because it's not very good. Oh well. It really isn't good. Could have done with a wee bit more length there. There's just nothing to actually connect onto really. It's so short, because that was already quite short. It was well back inside the material and the end of the section. So what I'll do is I'll power this up now. The moment of truth, it might be actually 24 volt tape. That would be exciting. It would be very bright, very briefly. So where is the quick test? There it is. Here's the quick test. So let's stick it into the quick test. What will happen? Let's make sure everything's pretty much clear before I do this, in case there's a little Armageddon moment. It's lit. So let's see what current it's actually going through it then. Let's use this meter. So I'm looking at roughly about a current of approximately, it says 7.3 watts, it says 31 milliamps. So that's roughly 15 milliamps per. I have to remember there could be live wires poking out the end of this. So yeah, this looks to me like it is just standard 220 volt tape that they've been selling us 24 volt tapes. I wonder how many people have bought it and just received a crinkly packet with this and just thought, what the heck am I supposed to do with that? And then it just doesn't get used, or they spend ages trying to connect 24 volts to it. So yeah, well, that was interesting. It was mildly amusing. I may try and terminate this properly. It's a nice shade of blue actually. It's a sort of like a soft sort of, it's nudging towards the greener side of blue, like a cyanish blue. It's quite interesting. But yeah, there you go. Getting random stuff from eBay and then trying to find ways to use it. So I was thinking, what could I use to spike into the end of that? And the answer was really easy. It was a 4-pin Molex connector. It has the perfect spacing. And all you have to do is grab the 2 middle pins with a pair of long nose pliers and just pull out those middle pins, and you end up with 2 pins that are just the right spacing, so that when you get an end of this material, and if you twist it either direction, the ends will, the actual wires, because of the sort of change in dimensions, will tend to stick out a bit. If you twist it like that, let's do it to that end because I've already marked polarity. If I marked polarity, I've marked polarity on one of these ends. It was that end. If you just twist them to cut it flush, where it just pops out, and then that way as well, and then you sit this connector in, it's just the right spacing and everything. So you just sit it into the ends of those, and it sort of fits in quite nicely once you can line it up. And then you get a pair of decent pliers and grip the 2 pins out the back and wiggle that in. Then it wiggles quite nicely up the end of that connector, and it seems to splay into the connections quite well. Another thing you could do, you could cut off that tab. I left that tab on because I thought it might actually help with securing it as well. So here's how I terminated this one. I did that. I put the Molex connector on, then soldered the rectifier onto it. And then to insulate it, the 2 connections here, I put a little piece of printed circuit board material in between the 2 rectifier, 2 pairs of diodes, and soldered the wires on either side, and then I squirted hot melt glue over the whole lot and then put heat shrink around it. And likewise at the other end, a smear of heat shrink, put the sleeving on, put more heat shrink down the end after it shrunk it on a bit, and then just squished it with the hot melt gun, so it, should I say that, the heat gun, so it like spewed a bit of the sort of hot melt glue right up the end as it shrunk, and it sealed it off completely. And this approach of the loose rectifier, it might look a bit crude, it might look a bit rough, but if you've ever dealt with the commercial tubelight with these ends, these rectifier ends that contain a bridge rectifier, that's exactly what's inside these. I know that because We occasionally had these fail on Christmas lighting jobs, and when they did, they'd just go dead short circuit, as rectifiers do. And it was sometimes silly things like the water actually going down the end here and crawling along the surface and getting in and shorting out the end. And with DC, it tends to flash over. Electrolysis occurs quite quickly, and it takes out the rectifier, and then you've got a dead end. You have to change the end on the tubelight after finding where the fault was. But that's actually what's in these. If you can imagine the two socket receptors up there, it's the pair of diodes soldered onto them with the correct polarity, and then that little spacer, and then the wire on, and then it's all just potted into the plastic when it's moulded, and then this outer sleeve is then added on to provide the outer sleeving connection. So yeah, I'm not sure if that's necessarily an approved way of doing it, but you know what, it seems to, the wires seem to go right up, they seem to slide in amongst the other connections nicely, just like they would with the traditional connecting method. So I don't see a huge problem with that, but obviously I couldn't guarantee, you know, longevity. I see one of the pins has pushed back through there, so it can get pushed in a wee bit further. That's better. But yes, it seems to, it's certainly probably no worse than the official connector, which just spike into it like that. So yeah, the four-way Molex connector, this also does allude to the possibility that because it's perfect pitch, that the spacing is literally 1/10 of an inch spacing in these again. As is so often the case, electronics industry uses 1/10 of an inch spacing quite a lot. So there we go. If you end up getting some of this stuff and it doesn't come with any of the connections, you can improvise them out of the four-way Molex connectors and a little bit of experimentation.